going to go, acknowledgements are going to be received, there's not going to be any errors. Of course, in real world that doesn't happen, so we have to now add more sophistication, and that's the entire noisy channel issue. And we will discuss more sophistication by involving what is called error control or automatic repeat requests, ARQs. Here it's A, R, and there's R, but it's always referred to as ARQ. Okay, request is represented by Q. Okay, so these are three protocols, just as we talked about earlier, and we'll go through one by one. The error correction in stop and wait ARQ is done by keeping the copy. You see that? Stop and wait, the keeping of the copy of the sent frame and retransmission of the frame when the timer expires. So if the acknowledgement doesn't come, what do? We have to have some provision. So what we do is take that stop and wait, just make a copy, and then wait for a certain amount of time for the acknowledgement. If it doesn't come, that means that, well, either the frame got lost in transmission or the acknowledgement didn't come back to me. But as far as the sender is concerned, it's time to send the same frame again till the acknowledgement is received. So that is stop and wait ARQ with the automatic timer, okay, for sending the thing. So, and there's also modulo 2 arithmetic that's used in numbering the frames, because you have to know which frame you're sending, right? So you number the frames as even, odd, etc. So you send the frame, and as long as the acknowledgement doesn't come, you stick to the even number. When its acknowledgement comes, you say, okay, this is the odd number frame, and so on. But there's only one bit that's required to know whether the frame is accepted or not. Another important aspect for you to remember is that the acknowledgement numbers are always, again, in the same modulo